Okay, how you doing, guys? Today we're going to look at polyprotic acids. This is a real short video lesson I'm going to do here. Essentially what it means is that the poly means that there's more than one proton that can be released from the acid. Remember, acids release hydrogen ions, which are protons. So with polyprotic acids, it's an acid that's capable of removing more than one. And you can typically tell that because you have hydrogens in the front with a 2 or a 3. That tell you that those are the hydrogens that are ionizable. Most likely the hydrogen in the front is the one that's going to be ionizable in the acids that you're given. We'll talk more about in the next lesson, maybe not the next one, but an upcoming lesson I'll talk about which hydrogens come off and which ones stay behind. Just keep in mind that when you're doing this, you want to bring the ions off in successive steps. You don't want to do this all in one shot, so you're going to do this in multiple steps. So for carbonic acid, you're going to take off one hydrogen ion and then a second hydrogen ion. So you can treat this as if it were two separate acids. Okay, each one having its own Ka, so this would be Ka1 for the first hydrogen and a Ka2. And keep in mind that this one is always stronger than the second one. Okay, because remember, the definition of an acid that we're focusing on is the fact that it loses a hydrogen ion. So the one that loses the hydrogen ion easiest is the one that's considered the strongest, right? So that's what we're talking about with the acids here. So Ka1 would be smaller. Okay, well, actually a bigger number, I guess I should say. It's going to be a larger number than the second one because that one's easier to remove. Again, we'll explain why in an upcoming later lesson. So really not much that they do with these polyprotic acids. The most complex thing would be just to figure out the pH, and your pH is always going to be dominated by your strong one. So for pH, use the stronger of the two, so that would be your Ka1. And if you're finding this one, just use if you're trying to find the concentration of the anion that's in there, go back to the common ion effect. Okay, and we've already talked a little bit about that, so I'm not going to spend the time doing calculations with that because one, it's not too often that you're going to see this, and two, I've already talked about it, so you can go back and look at some other stuff. The last thing I want to talk about with polyprotic acids is the sulfuric acid. This is the only polyprotic acid that's truly considered strong. Okay. Now remember, there's 7 strong acids that you should know, and sulfuric acid is one of them. And it's only the first one that's considered strong. So if I were to write that reaction for H2SO4, I would write this with a complete arrow, not a double arrow going back and forth, H plus, and then my bisulfate would be the anion that's left over, and this would have a minus charge. The Ka here, for the first one, there really is none. It's kind of pretty much undefined. Okay, it's really, really large. Okay, so it's extremely large if you want to say that. Okay, extremely large. Alright, so they don't really give you the K because you treat it like you would any other strong acid. Okay, so whatever the concentration of the hydrogen, the sulfuric acid ion is, H2SO4 concentration is going to be equal to your hydrogen concentration for that first step only. Okay, then we treat this one as if it were a weak acid with a Ka value. And that's pretty much it. And again, just like we said before, this first one would control the pH, and you would do another common ion effect if you were to try to find the concentration of the sulfate ion. And that's it. We'll talk a little bit more about polyprotic acids when we get to titrations, but that's pretty much it for this. So I just wanted to make sure there's a little lesson to kind of show you the basics of the polyprotic acids. Thanks a lot.